Okay, today we're going to do lesson 1.4, and we're going to learn how to find out if an equation or a certain number will make an equation a true equation or make an equation, or an inequality, a true inequality. So that means yes, it is a solution, or no, it's not. We've already talked once a few lessons ago about expressions. If you remember, an expression is just a problem with no equal sign. So, for example, it would be something like 2x. But when we have an equation, okay, it is going to be a problem that actually has an equal sign in the problem. So, 2x equals 8. That would be an equation. This is an expression. An inequality does not mean does not equal. That's not the definition of the word. The word inequality, as used in our algebra sense, means it contains a greater than or less than sign. So greater than or equal to or less than or equal to. This is considered an inequality. That's the type of problem it is, okay? So that's what each of these terms mean, and I want you to be able to use it correctly. So in this first problem, okay, or this isn't a problem, this is just more explanation. The equation is a problem that contains an equal sign. I want you to write this down. You need to know this definition. So go ahead and take a second and write this one down. Example number 1 wants us to find out, are 3 and 4 going to be solutions to the equation that they have given us? Okay? The equation they've given us, I know it's an equation because it has an equal sign, is 5x minus 7 is equal to 8. So they want us to plug in 3 for x, solve it out, and say yes, it's equation, or no, it's not. And then they want us to plug in 4. Solve it out, say yes, it's an equation, or no, it's not. So let's go ahead and we're going to plug in, we're going to start with 3. So I'm going to say 5, and then instead of the variable, the letter, I'm going to plug in 3 minus 7 equals 8. Now this is where we've got to pull from what we learned yesterday, order of operations, to know, do I multiply first or do I subtract first? Which one am I going to do, Sean? Multiply, perfect. So we say 5 times 3, which is 15. 15 minus 7 equals 8. Now if you notice here, I am not changing this side of the equation. It stays the exact same because I need to find out, will this left side be equal to or equivalent to the right side of the equation, okay? So 15 minus 7 is 8. Does 8 equal 8? Yes. So here we go. This is what I want you to do. This is your answer. 8 equals 8, and yes. You've got to have both pieces. Number 1, I need to see that you did your math right. So 15 minus 7 equals 8. So we did step by step here. I showed all the work that I possibly could. And then after I said 8 equals 8, I need to know that you know, yes, that would be a solution. They do equal each other. Okay? Now let's do the same thing but with 4. So I'm going to say 5. And then again, instead of the x, I'm going to plug in a 4. Minus 7 equals 8. All right, what would I do first? Josh? Multiply. 5 times 4 is 20. Solve again on this side. 20 minus 7 is 13. Does 13 equal 8? No. Again, both of those things need to be boxed in. Because here's the thing, is if you do this problem, and let's say you accidentally say, oh, 5 times 4 is 9. You accidentally add instead of multiply. Just a careless error, and then you say 9 minus 7 is 2. 2 does not equal 8. You would still get no as your answer, which would be half right, but you did the math wrong. So I could only give you half credit. That's why you've got to box in your answer and no, because I need to see that you know how to do the math, and you also know what makes it equal to each other or not equal to each other. Okay? Does that make sense? Okay, so example number 2, now they've given us 3 numbers. They want us to plug it in for this equation, and say, yes, it is a solution, or no, it's not. What am I going to be plugging in 5, 10, and 15 for? S, the variable, okay? So let's go ahead and let's start. We've got 12 times 5, replacing it, plus 5 equals 125. All right, Alex, what would I do first?
You would multiply 12 by 5.
Perfect, which is?
60.
60. Now I do my very last step. What's 60 plus 5?
65.
65. Does 65 equal 125? No. So here's our answer. No. All right, so let's see if 10 is going to be the solution. So we say 12 times 10 plus 5 equals 125. What's 12 times 10? 120. 120 plus 5 is 125. Does 125 equal 125? Yes, it does. So here's our solution. Now let's do the last one just to make sure. Okay, I'm going to do it right here on the bottom. We're going to do 12 times 15 plus 5 equals 125. What's 12 times 15? 180. 180 plus 5 is obviously 185. And does 185 equal 125? No. Okay, so here we go. Now, when you have equations, that means it has an equal sign. There can only be one solution. There can only be one solution because it has to be exactly equal to that number on the right-hand side. So technically, when I found that 10 was a solution, I already knew 15 was not going to work before I did any work at all, okay? Do I still want you to plug it in and do it? Yes, I do. It's good practice, okay? So let's review our inequality signs. I do want everybody to write this part down, okay? Everybody write this part down. So what it says is an inequality refers to a problem that has a less than or equal to, greater than or equal to sign. Not, I wrote the word in red so you would definitely see it, not when you plug in a number to a problem and it does not give you a solution. If you say, for instance, 25 does not equal 50, and you write inequality, you will only get half credit. Because in this case, that is not what the word inequality means. What the word inequality means is the problem contains a greater than or less than sign or some form of it. Does this problem contain that? No, absolutely not. It's actually, you're making it harder than it is. Your answer is a very simple no, okay? You're either going to have yes or no. That's the only two possible answers. Now, you will have to show your work, but the final answer is yes or no. Do not write inequality when your answer should be no. Okay, that's the main mistake people make. Now, let's kind of review our signs. Some people still get confused with greater than and less than. They're like, how do I know which one? Because it's not always going to be, oh, the smaller side points to the smaller number. Because you're telling me, yes, it's a solution or no, it's not. So it may be flipped around in the wrong way. And we've got to know the difference between the signs in order to be able to say yes or no. So here's the easiest way. This is what somebody taught me a long time ago, and I think it's the best way. If this is our two, or these are our two signs, which one of these looks like an L turned on its side? This one. That's less than. Anytime it makes an L, that's always less than. So if it doesn't make an L, that L obviously is totally backwards. It's not even a letter, okay? That is our greater than. That's the easiest way that helped me remember it, so hopefully that'll help you remember the difference between less than and greater than. Also, another easy way is if you hold up your hands, which one makes the L? This one. That's our less than sign. See, God gave you greater than and less than signs you didn't even know. All right? Okay, so our last example here, they want us to plug in a number to each of these problems. They want us to plug in 3 and say, yes, it is a solution, or no, it's not. Again, your answer is simply yes or no. I want you to box in the number that you get so I can see your work, but yes or no is our answer. The difference between equations and inequalities are that more than one number can be a solution. Remember on the equations, we had those 3 numbers, 5, 10, and 15. If 10 was the solution, we knew that 5 and 15 definitely were not going to be solutions. But when you're dealing with inequalities, okay, there's lots of solutions. Because let's think about it. If we said 2 is greater than 1, 2 would be a solution, but also we could plug in 10. 10 is greater than 1. 10 would also be a solution. So there's lots of other possibilities when you get into inequalities. That's why I said, even though you know it's not a solution, do it anyways, because when we get to these problems, you have to, all right? So let's take out our variables, which are, in this case, all x's, and plug in 3's. So in this first one, we've got 3 times 3. What is that, or minus 2, is, what is that sign right there? Greater than 5. Again, in this case, we're going to work on that left side. So what would I do first here? Order of operations. Carter? Multiply. 3 times 3 is 9. 9 minus 2 is greater than 5. So 7 is greater than 5. Is that a solution? Yes. Okay. Let's do the next one. I'm going to do it right beside it. We're going to plug it in. 3 plus 5 is less than 8. What's 3 plus 5? 8. Is 8 less than 8? No. Okay. Now, if it was less than or equal to, it would be a solution. But because there's no or equal to part on that, it's no. You say, but wait a second. The numbers on either side match each other. Doesn't necessarily mean it's going to be a solution. That's why you got to know the difference between the signs. Okay? Let's do the third one here. 3 minus 1 is greater than or equal to 2. What's 3 minus 1? 2. 2 is greater than or equal to 2. Does that one work out now? Yes. The total difference, what makes the difference, is that little or equal to sign. So this one is a yes. And last but not least, here's where our order of operations really comes in. 4 times 3 squared is less than or equal to 32. All right, what would I do first? Michael? Exponents. 3 squared is 9. 4 times 9 is 36. Whoops. 36 is less than or equal to 32. Is that true? No. Okay, so that's how we know inequalities. We can definitely have more than one answer, different problems. Okay, that completes lesson 1.4, equations and inequalities.